So similar to pOH being the same but the opposite of pH, right? It's a way of tracking the strength or the basicity of something, um, but relative to a base rather than relative to an acid. Um, Kb and Ka are really similar, right? They're both communicating the strength of a dissociation reaction. But we find that, like pH and pOH, we typically think about Ka instead of Kb. So pH and Ke are tend to be the published values that you'll see for reactions when you're looking them up. It's harder to find published Kb values. Um, but that's okay because we only need to know one of them. We'll always be able to figure out the other. And so I'd like to walk through that now and prove it to you. So let's start with just our simple acid dissociation reaction right here at the very top. So I have my acid HA, and it's going to, here we'll go like this, acid, and it's going to dissociate into the conjugate acid and conjugate base, where water is acting as my base. So that's my acid dissociation reaction. Now I can do the same thing for a base dissociation reaction. And I'm going to now, remember my A minus was my conjugate base. I'm going to take that conjugate base right here. So here's my conjugate base. And I'm going to think about what happens if I have that conjugate base as my base and I'm looking at a base dissociation reaction. Well, it'll react with water, right? So this will be my base. It'll react with water and it'll produce a conjugate base and a conjugate acid. Well, that conjugate acid that's produced was the acid that I already evaluated for my acid dissociation reaction. Uh, so it's kind of like flipping the equation, right? So I'm gonna take the sum of these two, and when I do, these acids are going to cancel, and these bases are going to cancel, and my net equation is going to be 2 water is going to be in equilibrium with hydronium ion and hydroxide ion. And so hopefully that looks familiar. That was our autoionization of water. And that is K characterized by Kw, right? Kw is equal to the concentration of our hydronium ion times the concentration of our hydroxide ion. So what I see here is the sum of these two reactions gives me my water dissociation or my autoionization of water reaction. And so if I combine these two, and remember back in chapter 13, we can pull those skills up and use them again. We talked about manipulating K values. And if we brought two equations together, what we would do to determine what their equilibrium constant was for the overall reaction is to take the product of those two equilibrium constants. That's what I'm going to do. I'm going to multiply Ka and Kb right here. Whoops. And when I do that, that's when I can see that this A minus, my conjugate base, will be on the top and the bottom of my equation, and my acid will be on the top and bottom too, and those can cancel out. And I'm left with H3O plus times OH minus, right, which is Kw. And so I get this overall reaction, which is Ka times Kb, or sorry, not reaction, overall expression is Kw. So if I know one, like Ka, and I know Kw, because that equilibrium constant is always 1 times 10 to the negative 14th, then I can calculate Kb. So if I need to look this up in as a published value to better understand a reaction I'm going to be doing in the lab, and all I can find is the Ka, it's not a problem because I'll be able to use this equation to figure out what the Kb is to help me be prepared for what I'm going to do in the lab. And remember, Kw is 1 times 10 to the negative 14th. So we can also rewrite this. We can take the negative log of the entire thing if we want. And that's going to give us this version right here, where the pKa plus the pKb is equal to the pKw. And the pKw is the negative log of 1 times 10 to the negative 14th. That value is 14. Remember, when we take the negative log of two values that are multiplied, it becomes the negative log of one of those values plus the negative log of the other one. And so that might just require a little algebra refresher if it's been a while. So we have two equations that we can use to readily convert between Ka and Kb, and it's all going to rely on Kw.